Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we talked about what exactly a game engine was. Make sure you check out that video if you haven't already. And before we begin, I just want to give a huge thank you to all of the patrons that make this series possible. If you guys aren't supporting the series, you can do so by going to patreon.com/thecherno to get access to these videos like a week early, as well as plenty of other cool rewards such as being involved in the planning process of these videos and finding out information about where this is going and actually influencing where this series goes as well. So huge thank you to all the people involved in that. So today, what we're going to talk about and what I thought we would talk about is actually just kind of going through some of the different things that are going to go into this game engine, because we actually do need to plan what we're going to be doing, right? And I've even got a little bit of a notepad here that I'm going to draw stuff on so that I can kind of really explain to you guys where this series is going to go, what we're going to do over the next few videos, and how I'm going to actually structure all of this and what this is even going to look like. So to build a game engine, first and foremost, is not an easy task, right? It's actually quite difficult to build a game engine. Because if you take a look at just game engines kind of in the wild, or game studios and how they kind of relate with game engines, you know that everyone except the largest of teams really usually goes with an already made game engine. And if a team does decide to build their own game engine, it usually requires a lot of resources, which is why it's not the best idea to kind of choose to kind of write your own game engine if all you want to do is make a game. Because there are other resources out there, there's no real reason for you to actually do everything yourself. That being said, because we're not a massive team, and because it's really only just me, I mean, I really want you guys to contribute, but obviously, understandably, I don't think that it's realistic for me to depend on consistent contributors, who aren't professional engineers who I'm paying. So because that whole thing doesn't exist, it's really up to me to build this thing and direct this thing. So I have to be reasonable with my scope. I can't say that we're going to build Unreal. I can't say we're going to build Unity or anything like that, because that's just completely crazy, right? And I'm here to actually try and make a game engine that will exist maybe, within the lifetime of the viewers who are watching this series. So because of that, there's a bunch of compromises that I have to make. And we're going to kind of take this slowly and by take this slowly, I mean we're going to end up iterating quite rapidly over certain features. And what I mean by that is we're going to focus on building up the minimal groundwork we need to actually get something working, and then we'll iterate over it and improve it and add more features and add more stability, add more performance and optimization, and do things like that. We're not going to try and write perfect 100% complete and powerful extensible code from the beginning, because that would take us like a year to actually get to the point where we have an application stack like on a window and all of that, because we'd have to do it so perfectly. We're going to kind of cut that out. We're going to rapidly go over this stuff, and I'll just probably end up just improving code over time, as well as you guys will contribute and help with that as well. So that's kind of the basic idea of how the series is going to run. The compromises that I'm making, we can get into probably when we get to them. I don't want to kind of spend today talking about, along the entire platform of what the game engine is. This is the stuff that I'm not going to have. Because if we start talking about that now, it's going to take a while, and it probably isn't going to interest too many people. But I mean things like having like a level editor. Like the level editor is going to be built into the game engine. It's going to exist in the game engine runtime. I'm not going to go ahead and build an entire C# WPF application that has its own kind of, it's a full standalone like Windows application that just links in with the game engine and then does all that stuff, because that's just unfeasible. It's going to take way too long. It would be the kind of my recommendation for if you had a huge team, I would probably do that, right? But because we don't have that, we're going to just end up kind of building a level editor out of like IMGUI or something like that within the game engine itself, and then that way it'll be all kind of C++, and it won't be the best solution, but it will be something that is achievable by us. That's an example, right? Shader compilation is another example. Like we could, ideally we'd write our own shader language and then have that compiled to Metal's shader language, to GLSL, to HLSL, to all of these kind of shader languages based on the platform that you're on. And that would be an amazing system that would probably take a year or two to build, right? So, by one person. So it's not something, we have to make compromises along the way. And I just want all of you to be aware that even though I really want to build an amazing engine this series, during, I guess this series is to build an amazing engine, I have to be realistic with what we're able to achieve. Now, that being said, there's no reason why you can't go back and then later add those features, right? It's just that when I'm talking about what the core technology that we're building will entail, like, I have been quite brutal maybe with kind of some of the compromises that we're going to be making, because you have to remember that apart from the fact that I'm one person building a game engine, I also have a full-time job building game engines for EA. And also, not only that, but I'm not just building an engine in my spare time. I'm teaching everything that goes into it. I'm planning. I'm doing all this kind of stuff. So because of that, it kind of ends up, not being as efficient, obviously, as if I just sat down for 10 hours a week or 2 hours a week and actually wrote code. Because if I did that, I'd have an engine in no time. But since I have to teach all of this, it obviously does take its toll in terms of time and efficiency. Anyway, enough of that. Let's actually dive in and take a look at what a game engine actually has, what we're going to do, and basically plan out our roadmap for the next few videos and this series. Now with plannings, I am going to have a major kind of design episode probably before I begin a massive new feature. For example, before we start building the renderer, we're going to plan out exactly how the API is going to look for that. So what the API for that is going to look like, how we're going to actually build that thing, and just the semantics of how everything's going to work. So let's dive down and take a look at the next few videos. Okay, so I really do want to kind of provide some kind of overview as to what our game engine, which, by the way, does not have a name at the moment. As of me recording this video, maybe I would have come up with one by the time everyone sees this. But I don't have a name for this engine right now. So if you have a name suggestion, drop it in the comments below, because I'm going to have to make a GitHub repository pretty soon. And that needs a name, obviously. So if you have any name suggestions for this game engine, just drop a comment below, and hopefully we'll come up with something pretty cool. Okay, so game engines, right? Let's start off by just kind of talking about exactly what goes into them. So the first point I want to kind of make is that we need an entry point, and an engine should provide some kind of entry point. Now, an entry point is essentially when we launch our application or our game that's been made with this engine, what happens? Right? This is something that a lot of people overlook. They think, okay, well, you've got your main function and you're done. Well, yeah, but what happens with that? What controls where the main function is? What controls the code that gets executed with the main function? Is that something that the client controls, or the game controls, or is it something that the engine actually controls, and maybe we kind of implement via either a macro or it gets imported somehow? What happens with that? If we break this down to primitive building blocks, when we launch our game, or when we launch our engine, what happens, right? What controls what happens? That's what the entry point is all about. Once we've kind of dealt with that, we have something called the application layer, or at least that's kind of what I call it. And the application layer is just really a section of our code that deals with application kind of lifecycle and events and stuff like that. So for example, our run loop, right? What keeps the application opening and rendering frames, right? What keeps the time going forward? What executes all of the code that our game wants to execute? What about events? What about things like windows being resized or closed? Or input events like mouse and keyboard, right? All of this kind of stuff is dealt with in the application layer. We need a way to basically run our game or run our engine as an actual application on whatever platform it's going to be on. That's where the application layer kind of fits in. From that, I kind of want to go into the window layer. Now this is kind of a interesting part of the engine, because if you think about a window, really a window is only something that exists on desktop platforms. It's like Windows, Mac, Linux, they have windows. And if you've done any kind of programming before, if you look at something like the OpenGL series that I have on my channel as well, we create a window. That's kind of one of the first things we do in our actual application. We create a window because that's going to be the target for all of our graphics rendering, as well as, where kind of input events are going to come from. It's our entire application is that window, right? On other platforms like mobile platforms, it's a little bit different. It's more or less kind of like a surface, because the app that you're kind of given an app rather than creating an app. And console platforms are kind of similar as well. So I'm really kind of talking about desktop platforms when I deal with window layer stuff, but because we are primarily going to be targeting desktop to begin with, and we'll talk a little bit more about platform support and rendering API support and all that stuff later in this video, But because we're kind of going to be primarily dealing with that, we're going to have a window layer. And inside that window layer, we need to deal with things like input and events. So input kind of gets put into events. So our event manager will handle inputs. We'll handle input events that get kind of picked up by our window and our application. Now, event managers are kind of a really important thing as well. We're going to build one that kind of functions on a very basic kind of messaging and broadcast system, which basically just means that certain kind of layers in our application can subscribe to events and get notified when events happen by the kind of application layer stack. When that happens, events will get propagated to those layers, and the layers can kind of choose if they want to propagate them to things like the entity component system, which we'll also talk about. So that's kind of how events will work. It's just basically a messaging system where we get interrupted when an event happens, or rather not really interrupted, but when an event happens, we get notified because our kind of on-event function essentially gets called. However, there's two parts to this, because with input events, for example, yes, it's really good to be notified when a key is pressed, but also sometimes we want to check the state of an actual input device. So for example, where is the current mouse position? Is the spacebar currently pressed, right? Those aren't kind of a messaging system. It's more or less us asking the application, hey, is this state the case, right? And if so, I want to do something. So it's kind of two parts to that, which again, we'll discuss when we plan out the events and kind of input system. From there, the renderer is probably one of the biggest systems that we actually have to deal with. Now, the renderer is what actually renders graphics on our screen. We basically tell the renderer, usually once per frame, hey, it's time for you to kind of go through your list of things that you need to draw on the screen and actually draw them, right? By far, this is going to be the biggest system of the engine and the most complicated. Now, I don't want to go ahead and say that the renderer is what basically the engine is, because a lot of game engine series, or like when people teach game engine programming, they always start with the renderer, they always focus on the renderer, and the renderer is just this huge thing that gets kind of built immediately, right? And I can't really argue with that, because the problem is, like, most likely when you're building a game, the very first thing you want to see are colored pixels on the screen, right? You want to see graphics. So of course it's going to be a good idea to kind of get that as soon as possible. And for me planning this series, this was a really kind of long discussion I essentially had with myself and others about whether or not I should start with graphics or whether or not I should maybe get a lot of stuff done. And the way that we're going to kind of order this stuff is we're not actually going to get to graphics immediately. We are going to pretty quickly have like a basic debugging layer up and, you know, just the ability to basically display text and maybe some other GUI kind of elements on the screen in kind of an application case. But we're not going to go ahead and build a 3D renderer in the first few months probably of this series. That's just not going to happen. The reason that's not going to happen is because, first of all, a game engine is much more than just a 3D renderer, right? So there's no need for us to kind of rush into that. But also, you're going to see how much easier it's going to be to actually build a proper 3D renderer when we have all of the other systems kind of already operational. It's just going to be an absolute breeze. Compared to what it would be if we have basically a raw bare bones application and we start writing like OpenGL code or DirectX code or whatever immediately. That's not a good long-term strategy. And we want to obviously take kind of the long-term strategy because we're trying to actually build an engine. The renderer, once we have all that, this, by the way, isn't necessarily a list that's in order. So don't think that, we're going to do the entry point first and application layer, window layer. This is just kind of all the stuff that's kind of going into this. So once we have the renderer, I keep saying once we have the renderer as if it is ordered, but we basically need some kind of render API abstraction, which basically just means that we're going to support multiple rendering APIs through our engine. Now, to begin with, we're just going to deal with OpenGL. The reason I've chosen OpenGL at the beginning is because I already have an OpenGL series that people can refer to, and also because, to be quite honest, it is the simplest API out there, and it's cross-platform, meaning that if we decide to have our code run on Mac and Linux, which I would like to get running pretty early on in the series, OpenGL is just going to work out of the box. If we went with something like DirectX, which might have actually been my first choice, it would be, first of all, more complicated to begin with, and I would have to spend more time teaching actual DirectX than writing the code, because I don't have a dedicated series for it, and because it is more complicated than OpenGL. Instead of doing all that, apart from doing all that, I would also need to, as soon as we have Mac and Linux, I have to implement another rendering API. But because our engine will support multiple rendering APIs eventually, like Vulkan, Metal, DirectX, OpenGL, all that kind of stuff, it's important to kind of design the renderer in a way where the API that you're actually using is abstracted. Meaning that when we decide to add an additional render API, it's not going to be this whole nightmare rewrite, because we've already set everything up to be pretty much API agnostic. Obviously, some things are going to have to be API specific. It's not like we can just write a function called upload texture and then implement that 4 times for each API, because the way that we want to create a renderer would be different based on the API, because Vulkan might be a little bit more efficient at doing certain things if you do it this way versus like the OpenGL way. So we kind of do still need to write 2 code parts, not just like every function that OpenGL has, let's create a copy of it, and then that's not going to work, right? And anyone who's done kind of multiple API programming will obviously know that that is the case. But we are going to design the renderer from the ground up in an abstracted kind of way so that we can deal with that. I'm going to summarize this entire section by saying basically debugging support. Now, this doesn't necessarily mean debugging as in I'm trying to fix my code, but just really, if you take the debug word out of that and you think about that, what does it mean to add debugging support to your engine or to an application? Basically, I'm just talking about essentially building your building with scaffolding around it, right? When we construct any kind of application, we need good ways to actually see what's going on and debug it and solve our problems and build something. So something like a logging system, right? That's something that might be really simple, but it's just something that we need to have, and we need to have it so that we can log any kind of data types that we have really easily, and we can log it to files and all of that stuff. What about performance, right? We've written our renderer fantastic, but it's a little bit slow. Well, where's all the time being spent? Well, in order to work that out, we need some kind of profiling system, right? We want to be able to basically have our application potentially run in a special mode that is outside of like Visual Studio settings. Like we want our application to actually do it itself so that we can run it on any platform and not have to worry about, using certain tools that are available on certain platforms. We want to essentially instrument the code, which means we want to put code into our code that only runs in like debug mode or something like that, which basically times every function and then collects it into like a nice kind of view, so that maybe then we can use some kind of tool to actually look at that and see, okay, cool, in my render function I can see the texture uploading or the uniform binding is taking up the most time. Maybe I've written that poorly, maybe I need to optimize that, right? That's something that's so important to have that people just kind of don't think about, because of course if you're writing a simple application you might not care about that stuff, but since we're writing something serious here, we want to have all these systems available to us because they'll help us a lot out in the future. I'm going to kind of accelerate through this a little bit because I feel like this video is dragging on, and as we come to other features we'll deal with them, but stuff like scripting, we want to have like Lua or some kind of C#, Python, I don't really care at this point, I haven't decided, but we want to have a scripting language kind of built in so that instead of kind of dealing with C++ code all the time, we can actually write scripts in much higher level languages that even like artists or content creators can write easily without having to think about stuff like memory. Speaking of memory, we obviously want memory systems, custom allocators and memory tracking, because I'll try memory systems, because memory is a huge deal for performance and also a resource that we really do need to manage well. And when it comes time to debug certain things as well, memory usage and perhaps even like CPU time spent on memory allocation is something that we obviously want to kind of be able to inspect and minimize as much as possible. An entity component system, or kind of an ECS, is as well something that we need to have. Entity component system, which is an ECS. This is just a way for us to be able to kind of create game objects in the world and then kind of modularize them, like be able to kind of include certain components, include certain systems to each kind of individual entity or game object we have in our world, so that we can kind of define its behavior and what actually the engine deals with. In the first episode, I talked about the fact that game engines are really just data transformation machines, where basically we just take in data and then the engine does something with them. Well, this kind of entity component system is a way for us to say, I have this object in my world. I want you to draw this 3D model at its position, right, at its transform. I want this script to be attached to it so that it can bounce around the room or something. I want it to have kind of a physics material so that it can actually interact with physics and all of that stuff. I want it to play this audio. You kind of get the point, right? It's just a way for us to be able to define what actually the engine does with an entity that we have, right? When we launch into a world or a scene or a level or something like that, we want to be able to load in all of our objects and then say, well, what actually happens to them? How do they work? What is the engine supposed to do with all this data that's coming in? And that's kind of essentially what an ECS is. Speaking of physics, we want some kind of physics solution. We'll deal with that probably a lot later on. I think that's about it. I mean, well, obviously there's like file IO and stuff like that, and also like a VFS, which is a virtual file system, that we also want to talk about later and design. I think that's about it. I mean, obviously we'll kind of have a build system as well and custom asset types. So if we have a 3D model or a texture, we have like 3D models or textures that get authored by content creators. We want to be able to convert them into a custom format that is optimized for our engine, so that we don't have to waste time transforming that data into our data at runtime. So we can kind of do that offline. We can do that by building our asset offline, and then it's really just really simple and easy to actually kind of just boot up our game and everything's in the right format and everything's the best. So we definitely need that. As well as, what was the other thing I was going to mention with that? Yeah, hot swappable assets, right? So we want to be able to, change, we want to have Photoshop open. We want to be able to kind of draw something on our texture in Photoshop, hit Control S. We want our build system to pick that up, build it, and then reload that into our game while it's all running in real time, so that we can kind of update stuff. Even like a 3D model, we can just kind of tweak some of the vertices or, modify it in some way, and it should just hot swap right into our engine so that we can kind of make changes to it while the game's running. That's another really important system that, again, probably isn't really that worth talking about right now. But it's just some of the stuff that's kind of, I'm planning to actually go into this whole kind of engine and project that we're building. Anyway, looking at the list, I think that's about it. I haven't covered any specifics, just kind of high-level systems. The way that this series is going to go is next time we're just going to start a project. As you know, I am a full-time software engineer at EA, so I don't have a billion years to make this series. So the best way for me to actually do this is we're just going to start writing code. I'm going to start explaining it, and wherever I write code that warrants a specific explanation, I might just make a video where I kind of draw diagrams and talk about it in more detail after it's actually been done. But the point is that the best way to actually write this massive engine and this overwhelming amount of work is to actually start writing it instead of spend a billion years talking about it. That being said, the code that I write will mostly be live. I will have already written, when we get to more complicated systems, like logging, for example, I will have already had kind of a logging solution ready to go that I will essentially just kind of write for you and explain how it works, right? And that kind of code will be available on a development branch to patrons way ahead of time. So that's a really good kind of thing for me to do, because that means that since it is available to patrons, those people can kind of read through it, help me out, point out some flaws, maybe say that, oh, this is way too hard to use, maybe you can simplify the API or something like that, and we can kind of iterate over that before it actually makes it into production and into these videos, which is another reason why I really need your support. So that's kind of exciting, and that's kind of the way the series is going to go. So next time we're going to make a project, talking a little bit about the constraints of this series, I guess, or kind of the way that this is going. For now, we're just going to support Windows only, and we're just going to support OpenGL only. I will write all of the code with other platforms in mind, meaning I'm not going to just write everything, like my application.cpp file is not going to contain Windows code in it, like Win32 API code in it, right? Because obviously the engine's going to support other platforms in the future. So I am still going to abstract things and make sure that I actually divide any platform-specific code or render API-specific code into its own kind of files that will not be compiled on other platforms, or if we're compiling for other rendering APIs. That all is going to be taken care of, don't worry. But for now, we're just making the assumption that this is Windows only, and we're going to be only dealing with OpenGL, okay? That's gonna basically hurry this up so that we can actually have an actual product, an actual project, like an actual thing in our hands before we actually go ahead and start moving on to more complicated things, because iterating over this is by far going to be the best way to actually have this done. So we're also not going to deal with like kind of like build systems or, you know, like CMake or anything like that at all for now, because that's just not really necessary. Once we do start talking about other platforms, whenever that might be, we'll deal with those things when we actually get there. Anyway, I hope you guys enjoyed this video. If you did, you can hit the like button. You can help support the series by going to patreon.com/Cherno. This is such a huge like series. I mean, even me talking about it right now, I didn't script this video or anything. I just had a few notes off to the side. This is like by far the biggest project I've ever done in my life. I'm gonna need so much help from you guys, but it's just such an exciting thing. I don't think anyone on the internet has really done something this detailed and this kind of highly produced, I guess, quality-wise. So I'm really looking forward to being able to do this for you guys. As always, you can help support me by going to that link, patreon.com/Cherno. I can't wait to see you guys in the next episode where we actually start writing code. See you guys later. Goodbye.